Yeah, so welcome to our workshop today. This workshop is about federated API management. So I did a talk yesterday on that, and this workshop is to get a little more in depth. And I'll have a look at the agenda in a minute, as we're a very small group. So if you just have any questions, raise your hand, speak up. We will get you a mic so that your question is also on the recording for the people joined virtually. Yeah, so let's just get started. So what are we going to do in the next 50 minutes? Well, first of all, if you want to follow along what I'm be doing on stage, you can do so. They need to access to the Wi-Fi here. You need Docker setup on your machine, and then you can just go to apida.com/workshop, and you get all the needed connection strings and information on there. But you don't have to follow along, right? So it's totally okay for you to just watch me doing things. What will happen during the workshop, we will do a quick introduction, a quick recap of the talk yesterday. So what actually is federated API management? Are there other architectures for API management? How do they look like? What's the difference between them? That's mainly to get every one of us here on the same page. Make sure that you also know all of the wording that I'll be using, the use cases I'll be talking about. And then we will set up a control plane for federated API management. We will connect it to some API management instance in Azure and in AWS. And we will create a consuming application that wants to place calls against these APIs, subscribe to them. And actually, we will see that for all of that, you just need the control plane. You don't need to dive into Azure. You don't need to dive into AWS. That's all managed transparently for you. And afterwards, then we will do some more talking about the control plane, what capabilities you should have in a control plane, how they should look like, how they should behave like, or what I would be very lucky to have more a type of a discussion where you basically discuss why you are looking into federated API management and if there are any questions that we can clarify. Because I absolutely want you to take something home with you today. All right, so let's switch over then. So very, very short recap of the talk from yesterday. So if you already attended that, sorry, but it just is, I think, necessary for the people who haven't attended the talk yesterday to get a little introduction into federated API management and what it's about. So from my perspective, the notion of a single full lifecycle API management is just outdated. So it's just not common anymore to have only one API management solution. Very basic example would be you're running an API management solution in your on-prem data centers, and now you make the move to the cloud, and you have some cloud-native workflows that you want to expose. And to do that, you would obviously not reroute them to your on-prem API management. That wouldn't make a lot of sense. So you set up a second API management instance in the cloud. So instead of one management interface, you now have two. And that is what we see is very common in the marketplace, and also within the industry, we see more and more people adopting that mindset that just one single API management platform doesn't cut it anymore. And if you compare it, for example, some years back when you developed applications, everyone told you you need to have that big application lifecycle management tool that spans everything from your requirements until delivery and spans the whole lifecycle, one big system. And if we look at how software is developed nowadays, it's the complete opposite. We use like 200, 300 different tools stitched together in pipelines. And that is basically what we at Apida predict for the future of API management as well. There won't be that one tool you use. You will use 10, 20, 30 different tools, one for design, one for testing, and so on. And that, of course, poses new challenges. And that view of the world is shared within the industry. Again, I'm doing just a quick recap, so I jump over those citations from yesterday. just keep in mind that the industry is moving in that direction. So this will be very common. That case of federated API management will be very, very common in the future. And the question is, what are we doing today to be ready for the future? Because if you imagine such a world where you have lots of different tools that might or might not be able to talk directly to each other, you end up with kind of like a mesh of services, of tools, that is basically an anarchy of tools. So everyone is talking to everyone, and you don't have that single source of truth that you would like to have in order to do proper API management. And that is basically where federated API management comes in, where our control plane comes in that we launched in December, as that strives to be exactly that single source of truth for your APIs. So we centralize, that is a quote by Eric Wilde, we centralize what you must. So centralize what really benefits you if it's run in a central way. So that is, for example, API discovery. So you want to have one place where all your APIs can be found, no matter where they are running. Especially if you publish public APIs, then people from the outside want that one place they can go to find all your APIs. They don't want to have 3 or 4 different places to find your APIs. They don't want to have to talk to 10 different people just to get to the one who can give them access to that API. They want to do that in full self-service. They want to do it at only one single location. So that is something that you absolutely have to centralize. And as such, discovery is also a big part of our product. Second thing you want to centralize is your provisioning workflows. So if you happen to have running multiple platforms, you don't want the hassle of having to use different languages depending on where your API needs to go. So you want to have one kind of universal language in which you define how your API needs to be protected, how the API management needs to set it up. And that should ideally be the same no matter where that API will run. So will it run on Azure? Will it run on AWS? You don't care. So if you want to compare it, you can compare it to the approach of Terraform, for example. You define your workloads one time, and you can push it to Azure, you can push it to AWS, you can push it to your own Kubernetes cluster, and so on. So the idea here is basically that. Define your workloads, define your API management, your protection once, and push it to wherever you see fit. And of course, security is also something that you want to handle in a centralized way. You don't want every team to come up with new creative ideas about how to achieve security. So security is something that should be the same throughout the whole organization. It should not depend on single people. It should not depend on teams. It should not depend on business units. If you are held accountable for the security of the APIs, that means that you need a standard that you can, that guides you, right? So you need a set of rules. You need to set a set of guidelines where you are compliant to. So that is something, defining these rules and checking and enforcing these rules, that is basically something that you also want to have centralized, just to make sure that if you are talking about security, everyone in the company is talking about the same thing and not 10 different flavors of it. However, things like API design, that is something that you don't need to centralize. You might have teams that have special constraints, which basically means they inherit their design from some backend system. You might have teams that use Postman. You might have teams that rather use Insomnia or any other design tool out there. There's no good reason to centralize design, apart from, might be convenient for your purchase department or whatever. But from a technical point of view, standardizing the design tool is of no need. What you need to standardize is the output. Again, governance, security. That is something that you need to standardize, not what tool you use. Same is for the gateway. If that API is running on Azure, on AWS, if it's running on Apigee, if it's running on Broadcom, if it's running on Kong, that shouldn't be of any issue for management tasks. Of course, it's an issue for the people that operate these systems, but from a more centralized approach, is there a reason why you should only use one gateway? No, there's absolutely not. There are good reasons to use more than one. So for example, if you have an IoT use case, why not use a specialized IoT gateway? There's no reason to not use these systems. Same goes for testing. So in short, the benefits that you get when you do not centralize these things but have the other things centralized, so basically doing federated API management, is you drive innovation, you can considerably reduce complexity, and of course you can increase the governance and security levels. And that brings us to architectures. And I switched to another slide deck for that because in this workshop, as we have more time, we want to have a closer look at the different architectures that you can run API management on. So all of these architectures are multi-plane architectures. And the multi-plane architecture, that is not something that is specific to API management. You also have it in like networking, you have it in other parts of IT administration. And it basically says that there is a layered approach to management. So you have that management plane where everything is happening that is not related to your gateway, that is not related to the actual data plane in any way. So for example, it's who has access, what are global considerations, and analytics data. That is something where the technical detail of where it is run is not important. I can define who has access to this API without even knowing if it runs at all or where it runs. So that is what the management plane cares about. The control plane, now that needs to have some knowledge of which data planes are used, because in the control plane, if we're talking API, this is where traffic shaping is happening. So where you define there are rate limits, there are quotas, all of that stuff. Of course, the quota itself or the rate limit itself doesn't depend on what data plane you're using, but the question if can I enforce a rate limit at the first place, that of course you need to know if the data plane is capable of doing so. And the data plane is where the actual API gateway is run. That is where the number crunching is happening. That is where all of the requests are fulfilled. And what you can find in most multi-plane architectures is that the two uppermost layers, the management and the control, as they are tightly coupled, they are most often just reduced into one layer, put into one system. And again, if we adapt that to API management, what we end up with is a control plane that has an administrative portal where you can configure your API gateway, where you configure your APIs, the protection and so on. And there is a developer portal where developers, third parties, consumers can get access to your APIs, like where's the API catalog, can I subscribe to it, what's the documentation like, the open API spec, and so on and so on. And as I said, the data plane is where the actual gateway lives in. And by the way, your gateway should always be as close to the workload you're proxying, right? For simple networking reasons. The latency between your gateway and your workload should be as small as possible. Now, when we take this architecture, the very simple one, and we add multiple environments, so you might have different stages, so you might have a development environment, you might have a testing environment, you might have a production environment, or if you are running multiple environments in like, okay, I have something that's run on-prem, and I have something that's in Google Cloud, I have something that's in Microsoft Cloud. So if we add the idea of multiple environments to the mix, then there are multiple architectures that you can use. You can use that single API management solution instance, which basically means you take one big gateway and put it in front of all your environments, right? So one single gateway, all the environments. However, that is probably a bad idea because you don't want your development stuff and your production data to be served through the same system, right? So you want to isolate traffic between development and production. Second reason why that's a bad idea is that if you have the other case where you are running one environment on-prem and one environment in the cloud, you don't want to use a common API gateway there as well. You want one that's running on-premise and you want one that's running in the cloud. So if you do this, you can just split it up. Okay, so instead of one gateway serving 3 environments, now each environment gets its own copy. It gets its own gateway, it gets its own control plane, because that solves your issue, right? So now you can put your gateway as close to the workload as possible, and now you can isolate the traffic from each other. However, this architecture creates a new problem, and that is now you have 3 control planes. You have 3 places where you administrate your APIs, and you have your 3 places where the consumer needs to go to get access to your APIs. And the worst part is your consumer needs in front of, or prior, before he can actually do something, needs to know where he is about to go. So the next iteration of API management architectures, that is called distributed API management. And distributed API management basically removes that disadvantage of having 3 control planes by just having 1 control plane, and that is able to control all of your data planes. So now you have the possibility to place your gateways as close to your workloads, and you have only 1 interface to manage it, 1 interface for your consumers to go to and subscribe to your APIs. That is an example for the layer 7 platform or for the layer 7 API management, but you could use any other vendor here. So it makes no difference if it's layer 7 for Broadcom, if it's Xway, or if it's Kong, or you name it. But the problem now is, what do I do if it's not all of the same, right? So in the example we just had, it was like 3 layer 7 gateways or 3 Xway gateways. But what do I do now if I have 1 layer 7, 1 Azure, 1 AWS gateway, and then throw in some more IoT gateways? Again, you can go for the separated architecture and just make copies of the different systems. Again, problem here is multiple control planes. We don't want that, so that's not a good solution. The solution to use here is what we'll be talking about in this workshop, the federated API management architecture. And the difference between distributed and federated is just that your API gateway can be of any brand. It can be of any vendor. So now you don't have to have 3 Xways, 3 layer 7, 3 Apidays. You can mix and match whatever you want. So, of course, you need a control plane that is capable of connecting to all these different systems. But if you have that, this is the architecture that gives you the most flexibility. Because everything that you need to do for management tasks, everything that your consumer needs to do, is only happening in the control plane. So it's not important what gateways are used, how many gateways are used, how they are set up. It's all taken care of by the control plane that does all the necessary translations. So this is basically, I'd say, an enabler for such an architecture, right? Because trying to run different brands of API gateways, of API management platforms without a federated control plane is just a waste of money and time. Because you will run into problems, and the only way to solve these problems is manpower. And manpower is always expensive. So that is the architecture that we are talking about. And what we will be looking at is the control plane of my company, of Apida. We will use that to set up an infrastructure that looks like that. So we switch over again. As I said, we will connect it to 1 Azure instance. We will connect it to 1 AWS instance. But you can connect almost any system there is outside. Now, the control plane is available online, so there's a free tier as well that allows you to play with it for up to 30 days, and then you have to decide if you would like to pay or if you continue on the free tier, which will still be workable but just reduces the number of options you have. So let's shut down that. And what we will be doing here in the workshop is basically create a federated API management platform from scratch. And do some of the use cases there to really, if you think about it, you probably think this is a very big undertaking. There's a big IT project. We will need like 10 different teams that are all aligned on that vision, that carried out. So it will take months and months and months until it's ready. And what I want to show you is that no, it's not. So you can do that very fast, very quick, and get some quick wins there. So we do create a new tenant at our system. All right, I need to agree to the terms. And now our tenant is set up. So you can try that whenever you have time available. If you want to play with it, you can do it afterwards. And yeah, I now get an email, but I can just access it as well. API Days demo. So I have to choose my password, and when you onboard, you should use something that's more secure than mine. And here we are. So this is the basic setup of the application, and for almost every control plane, what you have is like you have a bunch of environments that you connect to, you have a bunch of APIs that you manage. And of course, there's things around it. So you need to have consumers that are able to actually call into your APIs that do the requests. On our platform, we name them applications. You also find the name consumers, and in some systems, they are just reduced to the notion of API keys. But the concept is the same. It's something that element, that entity that wants access to your APIs. So let's go ahead and connect our platform. Again, I put the connection data if you want to follow along to our website. What do I call it? Workshop, I think. Yeah. So let's start with connecting our AWS environment. As you can see, these are the systems that we support right now. Upcoming are Apigee, MuleSoft, and a bunch of others. So we will be expanding our system space in 2023 considerably. And also, if you are about to choose a control plane for federated API management, make sure that it's extensible. Because it doesn't help you if the system is locked at a very few vendors. Now, if some new vendor comes along, or as I said, some of these niche gateways like IoT gateways, health gateways, and so on, then you absolutely want your control plane to be extensible so that you can just add a new vendor at any time. And the way that we do it, for example, is that we use agents to connect to the different systems, and we'll see that in a minute. And if we want to integrate another system, we just have to create a new agent. And the best is that we don't have to do it exclusively. So you don't have to pay us lots of money to integrate maybe some in-house system that you developed in your company. You can create these agents yourself if you want to. So let's go with AWS. Give it a fancy name. Give it a more AWS-like color. There you go. And now it asks you connection info because the system needs to know how to connect with the AWS. Now it's worth noting that this information is never transported to our servers. It's just used to generate the configuration files. So the credentials used to access the different systems, they are never stored on our side. They are just used or stored in the configuration files for the agent, and that agent is running within the secure zone where the gateway itself resides. So there is no administrative access happening from the outside. So let's just enter our data here. By the way, that also, or where you get that data is detailed in our documentation. So it tells you exactly where to click in AWS and Azure to get this information. So after that happened, we can download our configuration file, go next. In case you want to run the agent inside of a Docker environment, we do provide you with a ready-to-use Docker Compose file that you can use. Of course, you can also run the agent in OpenShift or in any other Kubernetes cluster out there. So download that as well. And we're good. Now, the control plane does now know about that Amazon environment, but as it does not initiate the connection itself, it needs to rely on the agent to be set up, the agent to start up, and we will do that now. So those are my two files. As you can see, I did that quite a few times during API days, so we have to fix the file names. And now we can just start up our agents. Yeah, come on. So that fix is something that you don't have to do, that it's just I have to do because I ran that demonstration quite a few times today at least. So now our agent boots up, and the view here is updated like every 15 seconds or so, but we can just switch over, and now we see that our agent is connected, everything is green, so our control plane is now connected to our Amazon environment. And we will do the same for our Azure environment as well. Again, the connection data can be found on this page here. Which gives us, again, the configuration file and the Docker Compose file to go with it. So boot that agent up as well. Need to rename them again. Whoop. And I can also show you that configuration file. There's not much happening in there. It's basically all the information that we entered. Again, this is not transferred to our server. This is just used to create that configuration file. You can also create that configuration file manually if you would like to do so. So we're ready for Azure as well. So we fire that agent up. And we should be now connected to Azure and AWS. Right, so we probably made some mistake here in the file, but that is fine. We just go with the Amazon one. And now as we are connected to the Amazon one, we can now discover the APIs. So we just go for discover. And what the system now does, as it is aware of all the environments, it's aware of Amazon, it now just goes and discovers the APIs that are stored on the Amazon server. And if we go to APIs now, it discovered that we are currently running three different sets of APIs within our Amazon environment, and that works for all the other environments too. So let me just shut down that one. Let's see if we can get that Amazon one to work, that Azure one. Just make sure I didn't make an error during copy and paste. No one needs Outlook right now. Okay. Okay, then just stick to the Amazon one for now. Okay, so what we do is we get all of the information. We got all the different APIs running on the system. And what we also get is we get the specifications of the different APIs. So we download the open API specs. We download the async API specs. If it's a SOAP service, we download the WSDL files and so on. And as we now have all the information about that API, we can, of course, assess the API. Because what I said in the introduction is one of the benefits if you do federated API management and you have that centralized element is that you can use it for governance. So you can use it to check your APIs for are they secure and are they high quality. Because the least thing you want to do is you don't want to have any insecure, any bad APIs published to the internet. So we get all that information and we automatically scan it for some best practices or for custom rule sets that you can define. So if you're in your company, define like all of my APIs should be working in this or that way. They should look like this. They should be only available through encrypted transport and not through unencrypted. Or you might impose some IP restrictions so that you filter out some IP blocks and so on. That is something that we can actively check. So that is especially important if you run something of a DevOps approach where the backend teams are allowed to publish APIs themselves. So instead of going to the platform team and tell them, okay, we have that new backend endpoint, please add it to the API management platform. You might want to allow the backend teams to do it themselves, to publish APIs themselves. But then, of course, you need to absolutely make sure that they are not publishing bad APIs. So you always want to check, is it syntactically correct what they are doing? Is it has it high quality, high reusability? Is it secure? So that's what you can check with the control plane, because the control plane knows about the rules. This control plane knows about the gateways. It knows about the APIs. And if you attach a system for quality control, it also knows about that. So it's basically some kind of central hub where all the information is aggregated, and that allows us to do these checks. What we're also doing is we get analytics data from all over the place, and we also can do things like, as I said, rate limiting, quotas, and so on. You can define that within the environment. So let me just quick switch over to one of our demo environments. because that has already some data configured into it. Oh, come on. There we are. So in that instance, the Azure agent actually did work. So I can show you that it does work. And as you can see here, now in this list, we have APIs running on 3 different systems that are connected to that control plane, right? So you're not limited in the number of things you connect. You are not limited in what kind of APIs you connect. And as I said, what the federated API management enables you is to aggregate all the APIs. It enables you to build up a catalog of every API that you have. So for example, you can also set up your developer portal. And I also open up a sample developer portal here. So you might not want to expose all of your APIs to the public, right? So some of them might be internal, some of them are not finished yet, you don't want to expose them. So beside being able to discover all the APIs on your systems, your control plane should also be capable of restricting access even within the catalog and even within your organization. So there might be some APIs that are only allowed to be seen and to be used within one business unit, but not from all of the company. So that is something that you also keep in mind. Basic idea, having all one APIs in one place is absolutely the right one, is a good one, but you should be able to segregate and isolate APIs from each other so that you can really set like this API is allowed to be seen from this part of the organization, this is allowed to be seen from this part, and this API is public, it's open for all, everyone can access it. So in this case, we have like 4 different APIs that we have in our catalog. For example, all of the information that you can see here, now the name, the description, and so on, that was automatically populated with all the data that we fetched from Azure in the first place. So I wouldn't say it's a no-click deployment, but of course it's not the big effort, so you don't have to register all of your APIs manually in such a control plane. At least you shouldn't. You don't need to in ours at least. So it all gets all the data automatically, and it has available also a capability of like defining plans, usage plans, and you can subscribe to your application, to your API with these plans. Of course, your catalog should also feature a sandbox where you can just test it out. That developer portal, for example, here uses Swagger UI. You might also use, for example, Bump as they are here on the show floor. You're not limited in that way, so you can use whatever you want. But you should absolutely have a sandbox in your catalog so people can actually try your API, see if the issue, if they have issues, is with their implementation or with the API itself. So always have a way for people to self-diagnose to see, okay, am I doing it wrong or is there actually a bug? And what we now do is we will now create a new application, so one of the new consumers, and push it down into the connected systems. So I create a new one here, which we just call Apidays Workshop Demo App. And this Apidays Workshop now has no subscriptions whatsoever. Right now it cannot access any API. We want to change that, so we create a new subscription and we subscribe it to the Pet Store API that is running on our Azure instance. We give it the medium plan and we tell it to subscribe. Now what the control plane now does is the moment you subscribe to an API that is running on Azure, it starts populating Azure with the needed data. Yes. Just have to do it twice here. It starts populating Azure with the needed data. So that application is now deployed to Azure and the subscription is now deployed to Azure, together with the information on what it can call, what are the rate limits, and so on. So for that basic workflow where you have like a consumer that's new to your platform and he needs access to an API, that can be done in complete self-service. So he don't need to have access to any of the guys, to any of the platform team. He just needs access to this portal. He can do that in full self-service, and everything is set up for him. So let's use one of the pre-existing ones here. So if that deployment is successful, he gets his API key. And as you can see here as well, there is no reason a consumer cannot subscribe to APIs from multiple platforms. There's just no reason. If you have let's say, a customer support application, it might need access to the APIs provided by your ERP system, so the customer can look into his last orders or stuff like that. You might also want him to connect to some other APIs. If you use one of the other architectures that basically duplicate the planes, where you have like multiple control planes, having one application that needs access to multiple systems means you have to go into multiple administration portals and get access there. So with our solution, you don't need to do that. This application has access to the Pet Store demo that we're running on our Broadcom instance and the Pet Store demo that we're running on our Azure instance. So we can now go ahead. I think that is the one here, and place a call there. However, that might fail because as we did quite some demos today, probably our usage rate or if our allowed usage is exceeded. So let's just check it. Yeah. So that error here means that our usage rate is exceeded. And you can see that if I use another API code, it gives me back a 401, not authorized. So the basic takeaway here is for everyday tasks, if you deploy a federated API management infrastructure, so for basic tasks, you should never have to go into the administration portal of the systems that the control plane controls, because that defeats the purpose. Of course, setting up APIs, doing initial configuration, you can do that in the administration portal of the platforms. No problem, right? But everyday tasks should be done in a highly automated fashion only through the control plane, because otherwise you will not get the benefits. And setting up or adding, integrating a new platform into a federated API management architecture into the control plane, as I said, that should be as easy and as straightforward as it gets, because that is where you will have problems if you grow your infrastructure. And just imagine that all the integration is full custom. So you always have to go to the vendor of your control plane and say, okay, I need another integration. Now, what do you do if you're not happy with his price tag? Nothing. You have to pay the price. With an open infrastructure, an open architecture like ours, where you basically, if you're not happy with us doing it, can do it yourself, that greatly limits your lock-in, because you can always add new integrations yourself. You can swap integrations if you don't trust us that we're doing our job right and you want to create your own agents to make sure it follows security best practices or whatever. You're free to do so, right? So with everything we do, we always follow an open approach. So we are very happy to assist you. We are very happy to get the project underway with you. But if you decide to do it all on your own, that's fine by our books. Okay, so we still have some minutes to share. So let's hop back and give you a quick wrap up before we might have talk about any questions you might have, anything where you need some more clarification. Again, the capabilities of a control plane. No, we don't want the Explorer now. It should be able to discover all your APIs. It should do it automatically. You absolutely want it to manage your consumers, your API keys, and you absolutely want to get it and aggregate metrics or analytics data, because what you need to know, for example, the teams that are consuming the APIs, is how many calls did we place? And were they successful? Did they fail? Why did they fail? And again, you don't want to make your consumer jump through 3 different systems to get these numbers. You want them to give them one place of access for all of these things. Because otherwise, they will be bothering the platform team. Oh, can you give me usage data? I need usage data. Ah, that's only Azure. I need AWS as well. So you don't want to put all that manual effort in. As I said, all of the problems that federated API management solves, you can also solve by manpower, right? But you don't want to do that. You want to work on your infrastructure, you want to work on your platform, you want to make it better, you want to provide a better experience. You don't want to hustle around trying to collect reports for your consumers. Control plane should work the other way around as well. It should not only be about consuming stuff, it should also be about publishing new APIs, bringing new APIs online, and it should help a lot with governance. So make sure you check security, make sure you check quality to really benefit from the API program that you run within the company. So let's look at some use cases before we finish up. As I said, most common one is you already have some system that's running on-prem and now you're moving into the cloud. You have new workloads that are cloud native, that are serverless. You don't want to bring your API management that you have on-prem, put it in the cloud, and then put some serverless application behind it, right? So you want to go cloud. If you go cloud native, then go full cloud native. If you go serverless, go full serverless. So you end up with more than one management platform. Second use case might be group structures, where you have a centralized IT that basically has to take the blame if something doesn't work, but can't decide what the business units are actually doing. So every business unit might have their own API management. They might want to use their own tooling. And federated API management allows that, so every business unit can still use whatever they see fit for their task. If they only have IoT workloads, then use an IoT gateway. But central IT can still care about governance, can still care about accounting, it still can care about security of all of the APIs. So that's basically the wrap up for today, for the workshop. We are at our booth right outside of the door to the right. So if you want to have a chat with us on that topic, feel free to do so, to visit us.